One of the most fascinating and widely discussed astronomical events in recent years is the potential supernova explosion of Betelgeuse, a red supergiant star prominently located in the famous shoulder of the constellation Orion. This enormous star, nearing the end of its life cycle, has captured the attention of both professional astronomers and casual stargazers around the world. What makes Betelgeuse particularly intriguing is not only its size and brightness but also its unpredictable and dramatic changes in appearance that suggest it may be approaching the final moments of its existence. In late 2019, a startling event occurred. Betelgeuse, usually one of the brightest stars visible in the night sky, began to fade noticeably. Even to the naked eye, observers could see that something was different. Over several months, the star's brightness dropped so significantly that many wondered if they were witnessing the death of a star. It was an unprecedented dimming for a star so well known and studied. Scientists around the world turned their telescopes to Betelgeuse, hoping to understand what was causing this sudden and mysterious decline in light. What they found was both surprising and fascinating. The great dimming was not just a simple fading but was accompanied by evidence of massive ejections of stellar material from the star's surface, creating dust clouds that partially obscured its light. These findings have led many to speculate that Betelgeuse might be close to exploding as a supernova, a spectacular stellar explosion that would mark the end of the star's life cycle. But despite decades of study and recent intense observation, the exact timing of such an explosion remains one of the great mysteries in modern astronomy. Betelgeuse is situated on the upper right shoulder of Orion the Hunter, one of the most recognizable constellations in the night sky. Its alternative name, Alpha Orionis, denotes its status as the alpha star in Orion, typically a designation reserved for the brightest star in the constellation. Although Betelgeuse is not the absolute brightest star in Orion, Rigel holds that title. It is nevertheless remarkable due to its massive size and distinct reddish hue, which set it apart visually and scientifically. The name Betelgeuse itself has an interesting origin. Derived from Arabic, it means, the armpit of the giant, a poetic reference to its position in the figure of Orion. This red supergiant ranks among the top 10 brightest stars in the sky and is the 7th brightest star visible from much of North America, Europe, and Canada. Its imposing glow has made it a staple of the winter night sky for observers throughout history. One of the key characteristics of Betelgeuse is its tremendous size. Estimates suggest that the star is about 1,000 times larger in diameter than our Sun. To visualize this, imagine the Sun expanding until it nearly reaches Jupiter's orbit. At such a scale, Betelgeuse's outer layers would engulf the orbits of Mercury, Venus, Earth, and Mars. This giant star is so large that it loses about 1 solar mass every 10,000 years, ejecting material into space in all directions. The result of this mass loss is a vast, glowing nebula that surrounds the star, extending about 30 astronomical units, the distance between the Earth and Sun, making it roughly 250 times larger than the star itself. At the core of Betelgeuse, powerful nuclear fusion reactions continue to drive the star's immense energy output. Like our Sun, Betelgeuse initially fused hydrogen into helium, releasing energy that balances the crushing inward force of gravity. However, Betelgeuse has long since exhausted the hydrogen in its core and moved on to burning heavier elements. Now, helium and carbon are fused to create energy. Eventually, neon and carbon react to form iron in the core. This stage is critical, because unlike previous fusion reactions, fusing iron consumes energy rather than releasing it. When iron accumulates, the star can no longer sustain the balance between gravity and pressure, leading to the catastrophic collapse of the core. This gravitational collapse triggers the star's ultimate fate, a supernova explosion. When Betelgeuse goes supernova, it will release an unimaginable amount of energy, one of the most powerful explosions in the known universe. Such an explosion will outshine entire galaxies for weeks or even months and send shockwaves of energy and material throughout the cosmos. Stars emit different colors depending on their age and the processes happening within them. Young stars tend to be bright blue, while older stars like Betelgeuse glow a deep red. Ancient astronomers took note of Betelgeuse's distinctive hue. Ptolemy, the Greco-Roman astronomer of the 2nd century AD, described the star's color as ruddy or red. Chinese astronomers of earlier centuries observed it as a yellow star, suggesting that Betelgeuse may have undergone significant changes in color over millennia, possibly transitioning from a yellow supergiant to its current red state. Massive stars like Betelgeuse live fast and die young, consuming their nuclear fuel at a much more rapid rate than smaller stars such as our Sun. While the Sun's lifetime stretches over about 10 billion years, Betelgeuse's life expectancy is measured in mere millions of years. This rapid evolution is the reason why it is already approaching the final stages of its existence. Betelgeuse is known to undergo regular cycles of brightening and dimming, linked to the expansion and contraction of its outer shell. One notable cycle lasts roughly 5 years and spans about 100 days. During these cycles, the star's diameter and surface temperature fluctuate, leading to changes in its overall brightness. These pulsations are natural for red supergiants but can sometimes produce unusual or dramatic effects, as seen in the dimming events of recent years. The 2019-2020 dimming episode drew unprecedented attention. Betelgeuse's brightness dropped so drastically that it sparked speculation that the star might be nearing a supernova explosion. Yet, the star eventually recovered some of its brightness, adding complexity to the picture. Some astronomers now believe that the dimming was primarily caused by dust clouds formed from a massive surface ejection, rather than the star collapsing imminently. Historical records of Betelgeuse extend back over 2 millennia. Despite this, the causes behind its irregular brightness changes and mass loss episodes remain poorly understood, making it one of the most enigmatic stars in our galaxy. Betelgeuse moves through the interstellar medium at a speed of approximately 30 km per second, having been ejected from the Orion OB1 Association, a group of massive stars including those in Orion's famous belt. As Betelgeuse plows through space, it generates a shockwave extending over 4 light years, further influencing its environment and shedding material into the galaxy. Measuring the precise size and distance of Betelgeuse has proven notoriously difficult for astronomers. The star is a pulsating variable, which means its size changes with time. Additionally, the complex envelope of gas and dust it ejects absorbs and scatters light in ways that complicate observations. Its apparent size varies depending on the wavelength of light used to observe it, with measurements differing by as much as 35% across the electromagnetic spectrum. In July 2009, the European Southern Observatory, ESO, published stunning images captured with the Very Large Telescope Interferometer, VLTI, revealing an enormous plume of gas extending 30 astronomical units from Betelgeuse's atmosphere. This was one of several massive ejections observed around the star, each offering valuable clues about how red supergiants lose mass and prepare for their explosive deaths. Despite modern instruments and techniques, the complex dynamics of Betelgeuse's atmosphere and mass loss remain a scientific puzzle. Understanding these processes is crucial because red supergiants like Betelgeuse play an essential role in the galactic ecosystem by enriching the interstellar medium with heavy elements forged in their cores. The unprecedented surface mass ejection observed in 2019 was especially dramatic. Researchers using the Hubble Space Telescope and other facilities found that Betelgeuse expelled material with an intensity thousands of times greater than typical solar events. This ejection released roughly 400 billion times more mass than the largest coronal mass ejections produced by our Sun. This enormous outburst is believed to be the main cause of the star's rapid brightness decline in late 2019. By February 2020, Betelgeuse's luminosity had dropped by about 3 times, falling from magnitude 0.5 to 1.7. However, in mid-February, the star's brightness stabilized and remained steady for over a week. Moreover, no significant changes were detected in its infrared emissions, indicating that the star's core had not collapsed during this period. All these observations point to Betelgeuse's dynamic and unpredictable nature as it approaches the end of its life. While no one can say exactly when the star will explode, its behavior provides valuable insights into the complex processes governing the late evolutionary stages of massive stars. From a cosmic perspective, the eventual supernova of Betelgeuse will be a spectacular event, visible even in daylight from Earth. It will provide scientists with a rare opportunity to observe a stellar explosion in detail and to study the aftermath as the star's remnants enrich the galaxy with heavy elements essential for the formation of new stars, planets, and ultimately, life. For those interested in spotting Betelgeuse in the night sky, it resides in the upper left corner of Orion's distinctive hourglass shape. Its bright, reddish-orange glow makes it easy to identify, especially during the winter months in the northern hemisphere. With even a modest telescope or binoculars, amateur astronomers can observe the star and track its fascinating variability. As we continue to monitor Betelgeuse, the question remains: are we witnessing the final stages before a monumental supernova explosion, or is the star simply going through one of its natural cycles? Only time will tell. What do you think? Is Betelgeuse ready to burst into one of the most dazzling explosions in the universe, or will it continue to surprise us with its resilience? Share your thoughts in the comments below. If you enjoyed this deep dive into one of the cosmos' greatest mysteries, please like this video and subscribe to the channel so you won't miss our future explorations of space and science. Thank you for watching, and until next time, keep your eyes on the stars, because the universe is full of wonders waiting to be discovered.